If you're new to my channel, please consider subscribing and hit the notification bell so that you don't miss out on any new videos. Today we're going to look at how to differentiate using the quotient rule. So for a function y is equal to u over v, where both u and v are functions of x, to find dy by dx, someone might decide to rewrite this as say u times v to the power of minus 1, and then you apply the product rule. Yeah, then you apply the product rule. It's also okay, it's possible, you can do that. But now this is not the smartest way to differentiate a quotient. Why? Because it gets difficult if the denominator cannot be expressed in that form. So now to differentiate a quotient, we say dy by dx is equal to v times du by dx minus u times dv by dx, all of this over v squared. So this is what we call the quotient rule, for which both u and v will be functions of x. So now let's attempt those questions by differentiating using the quotient rule. So for the first one, we've got x minus 3 squared over x. So now the numerator, of course, would be our u, then the denominator being our v, function of v. So now dy by dx is equal to v being x, times du by dx. So now differentiating x minus 3 squared, we know that, allow me to just replace that by a multiplication sign, or maybe a square bracket here. So differentiating that function using the chain rule, the numerator, we're dropping the power 2, multiplying by our linear function x minus 1, then subtracting 1 from the power of 2 to get a 1, then multiplying by the derivative of what's inside the brackets, which is also a 1. So we simply get 2 times x minus 3 being the du by dx, then minus u being x minus 3 squared, then times dv by dx. So now differentiating x, we simply get a 1. And then we are putting this under the denominator. So we are saying over the denominator v squared. So v squared, we're just squaring x squared like that. So now to simplify this, we're not just going to remove the brackets. So we are saying 2x times x minus 3, then minus x minus 3 squared, right? All of that over x squared, which we can further simplify to, here if we can factor out x minus 3, we're saying x minus 3 into 2x times x minus 3 will give us 2x. Then minus x minus 3 into x minus 3 squared, we simply get x minus 3. Then from there we can remove these brackets. This is under the, this is now what? Over x squared. So now we're saying x minus 3, then 2x minus x, we get an x, and then minus 1 times minus 3, we get a plus 3 over x squared. So now this becomes the solution. And of course, we know that's what? We can expand this, remove those brackets, and that will give us x squared minus 9 over x squared. Right. Putting each of these, splitting this, we are saying x squared over x squared will give us a 1 minus 9 over x squared. So now that becomes the answer for the first part. Now let's go on to differentiate the second question using the quotient rule. So allow me to erase this part. Okay, so now for the second question, we know the numerator is our u, function of u, and then the denominator v. So dy by dx being v times du by dx, we are saying this will be equal to v x to the power of 3 times, we put a square bracket again, so x to the power of 3 times du by dx. So differentiating the numerator using the chain rule, we're saying 3, dropping the power 3, multiplying by our linear function, subtracting 1 from the power of 3, we get a 2, then multiplying by the derivative of this linear function, which is minus 2. Then minus v times, u times dv by dx. So u being 1 minus 2x raised to the power of 3 times dv by dx. So differentiating the denominator, we simply get 3x squared. And then now that we're saying all over v squared being x to the power of 3 squared, which will simply be x to the power of 6. So now we can further on go to simplify this. So here if we say 3 times minus 2, we get a minus 6, x to the power of 3 times 1 minus 2x squared, then minus 3x squared, 1 minus 2x to the power of 3, like that. All of this over the denominator of x to the power of 6, like that. Right. So now we can go on to simplify further as well. So we know the common factors, there's definitely minus 3x squared. So there's minus 3x squared. And then there's also 1 minus 2x squared. So minus 3 into minus 6, we get a 2. Then x squared into x to the power of 3, we get an x. Then x, the squared is 3. And then 1 minus 2x squared into 1 minus 2x squared, that will give us a 1. Then minus 3x squared into minus 3x squared, we get a plus 1. And then this 1 minus 2x squared into 1 minus 2x to the power of 3, we'll get a 1 minus 2x. Like that. And you know this is over the denominator. This is over, we put those square again. So this is over x to the power of 6. Right. And then now we can further on go to simplify. Now we're just simplifying that, removing those square brackets. So we're saying minus 3x squared times 1 minus 2x squared times 2x minus 2x, this is a 0, then you get a 1. So times a 1, we should just simply give us that. That over x to the power of 6. And x to the power of 6, x squared, x to the power of 6, we can simplify that as well to get minus 3, 1 minus 2x squared over x to the power of 4. So now that would be the final answer for the differentiation of this question. So now let's move on to look at the last part. Oh, okay. I wasn't supposed to use that. So this is over v squared. Over v squared, like that. Okay, so now for the last part, we're saying we want to differentiate 2x squared over x minus 2, whereby 2x squared is our u, and then x minus 2 is our v. So we're saying v, which is x minus 2, times du by dx. Differentiating the numerator, we are saying 2 times, dropping the power 2, we get a 4x. Subtracting 1 from the power of 2, we get a 1. Then minus u, which is 2x squared, times dv by dx. Differentiating x minus 2, we get a 1. Then we're saying this is over the denominator of v squared, which is x minus 2 squared. Then we simply break this down. So we're saying 4x. Okay, here would rather just remove these brackets here, such that 4x times x, we get 4x squared, and then 4x times minus 2, we get minus 8x, then minus 2x times minus 2x squared times 1, we get minus 2x squared, over x minus 2 squared, which we can simplify further to 4x squared minus 2x squared, we get a 2x squared, minus 8 over x minus 2 squared. So now this would be our final answer. Let's see if we can simplify. Yeah, we can even further simplify it as well. So in the numerator, if we factor out 2, we get x squared minus 4 over x minus 2 squared. But what do we know about x squared minus 4? That is difference of 2 squares. So that will simplify to 2 times x minus 2 times x plus 2, sorry. X minus 2, x plus 2 over x minus 2 squared. So x minus 2 times x minus 2. Then that will cancel. Such that we've got 2x plus 4 over x minus 2 is the final answer. So now this was differentiating using the quotient rule. So please feel free to leave a comment, drop a like, and subscribe. Thank you.